Hello Math 30-1 and welcome back. In today's lesson, lesson 4 of functions and relations, we're going to be looking at the quotient of two functions. So we've already looked at the product, the sum, the difference, and now we're looking at the last one, the quotient. I was nice here for this exploration. I'm going to start you off on it, then I expect you to finish it. But I was nice here, and I kind of did all the points from this ahead of time to save you some time. Now it wants us to divide f of x by g of x. We divide this value by that value. Okay, so here we're going to have 6 divided by 1, which gives me 6. 0 divided by 0 now, can you divide anything by 0? Well, how do you put anything into 0 groups? You always have to have a group, so this is undefined. I think if we had 3 people and I want to divide it by 0 into 0 groups, how do I make 0 groups? It just doesn't make sense. So now we have negative 4 divided by 1, which will give me 1, which gives me 4. Negative 6 divided by negative 2, which will give me 3. Negative 6 divided by negative 3, which gives me 2. Negative 4 divided by negative 4, which gives me 1. And I think we see the pattern here starting to form. And then we have 0 divided by 5, 0, and then 6 divided by negative 6 is equal to negative 1. Now, if I was to graph this, we have one section that is undefined, okay, and that is when x is 2. So to graph this, we first have, at 3 we have 6. So let's go over at 3, 1, 2, 3, we have 6, which is right there, okay? Now, at, what's another one? At 1, and this looks linear if you notice we're counting by 1. Let's go at 0, we have 3. So at 0, we have 3. And now I'm just going to connect these lines, just like this, okay? So it looks something like that. But we said at 2, it is undefined. Oh, that's a bit off. Let's see, we have 0 at negative 3. Yeah, we're at 0, that's close. So we're a bit off at one spot here. At 2, right there, so at 2, it is undefined. So I'm going to have to erase this here. I'm going to put a little circle, which means undefined. So it never actually reaches 2. That's kind of like our limit. Now, I want you guys to finish this rest of this exploration by yourselves, and I'm going to check to make sure you did it tomorrow in class. Okay? So here we go. Let's start with our first class example. In each case, write down and simplify, where possible, the quotient of f of x and g of x. Okay? F of x by g of x. So, include any domain restrictions. Now, if I wanted to do this here, we have to go to x plus 5, and this is all divided by x plus 5. Now I look at this, what cannot be equal to 0? I cannot divide by 0. So I know x cannot equal to negative 5, because x plus 5 cannot equal to 0, and I subtract 5 from both sides, I'm going to get negative 5. Okay? Remember what this is called? This is also called a non-permissible value, which we would have learned in years before. Now it wants us to see if we could solve this the best we can. I cannot solve this, so I have f over g of x is equal to this. I can't simplify that anymore. Let's take a look at the next one. So we want f over g of x. So we want f over g. So here's f, x squared, minus 2x minus 35, all over x subtract 7. Well, once again, I know x cannot equal to 7. Okay? So I make this equal to 0. I can't divide by 0. It's my non-permissible value. Now this top here, I believe I could factor. Okay, do my trusted box method here. I'm going to have negative 35 and 2. Well, that's 5 and 7, so I have negative 7, or positive 7 and negative 5. So it's going to be x I think it's positive 7, negative 2. Nope, this is negative 2. So negative 7 and positive 5. So we have x minus 7, and we have x plus 2, or x plus 5, all over x minus 7. So these cancel off, and I am left with just x plus 5 is my solution. But x cannot equal to 7. Okay? So that's my equation. Let's take a look at the next one. So we have x minus 2. So I'll just write that in. It's equal to x minus 2 all over x squared minus 5x plus 6. So I'm going to have to factor this bottom there. Okay? So I want two things multiplied to give me 6, but when we add them it gives us negative 5. So I'm going to have x minus 3 and x minus 2. Okay? So we have x subtract 3, x subtract 2, all over x subtract 2. Now before we cancel, I have to state my non-permissible values. X cannot equal to 3 or 2. Okay? So those are two things that x cannot equal. And now these can cancel off, so I'm left with 1 over x subtract 3. That's my answer, but x cannot equal to 3 or 2. All right, let's take a look at example number 2. Here we have 2x squared minus 13x subtract 7 for f of x, and g of x is 2x plus 1. Now it wants us to first state the domain and range of f and g. Well, for both of these, x could equal all real numbers. There is no restriction on the domain. So the domain is x is an element of all real numbers. Okay? Our range, though, there is a slight restriction. Now it says, write an expression in simplest form of the quotient of f divided by g of x. We want f over g, and this is over x. Okay? Let's put this out. We have 2x squared minus 13x subtract 7 all over 2x plus 1. Well, we could already start solving for this and state my domain. Well, we could help. We could find my non-permissible value. X cannot equal to negative 1 over 2. Now, if I want to find the top and simplify this, I'm going to have to factor. So how do I factor that? Well, this is a bit difficult. I'm going to go back to my trusted box method. 2 times 7, negative 7 is negative 14. And here we're going to have negative 13. That's going to give me negative 14 and 1. Okay? So we end up getting negative 14 all over 2x, and we have 1 all over 2x. This can be simplified to negative 7 over 2 over x. Okay? So I have x subtract 7, and we have 2x plus 1 all over 2x plus 1. Okay? These cancel off. I'm left with x subtract 7. Okay, there we go. And remember, x cannot equal to 1 over 2. So what is my domain? For this one, my domain is, we have x such that x cannot equal to negative 1 over 2, and x is an element of all real numbers. So that is my domain for this one here. Okay? Let's take a look at this next part. This is explain 2 different ways of evaluating or calculating that. Well, we could go way 1 or way 2. First way I could do this is I could put in 3 for each of these and divide. So I could go 2 times 3 squared minus 13 multiplied by 3. And then I could have subtract 7, which is equal to, so I do f of 3 first, okay, which is equal to this, which is equal to, I end up getting 9 times 2 is 18, 18 minus, minus 39, 18, negative 39, negative 36. I put that into my calculator. gives me negative 28 in my calculator. Now we also have to do g of x. So g of 3 is, we have 2 multiplied by 3, and then we're going to subtract, so we have to put in 3 for x, or plus 1, which ends up giving me 6 plus 1 is 7. And I go negative 28 divided by 7 gives me 4. Okay? Now the other way of doing it is, negative 4. The other way of doing it is using our simplified thing. So I just have f over g of 3 is 3 subtract 7. So I put in that 3 for x, which gives me negative 4, which could be a lot faster. If we had many different things to plug in, this way here is quite a bit faster. So here we go. Let's take a look now at example number 3. Consider the functions of these. All right? State the domain of f and g. Well, what is my domain of f? Well, we know for f of x, in f of x, we have, my domain is, x can be an element of all real numbers, okay, where x cannot equal to 1. Okay? Now, if we look at g of x, the domain is x can be an element, x cannot equal to 3, and x is an element of all real numbers. I'll put this down so you can see. Okay? Now we want to know, it says evaluate 3 multiplied by f of g and 2. So first of all, I'm going to multiply f and g together. So what is fg of x? Okay? So I want to find fg of x first. So that's going to give me 2x all over x minus 1 multiplied by x all over x subtract 3, which will end up giving me 2x squared all over x minus 1 multiplied by x subtract 3. I could expand this and combine that if I wanted, which will give me 2x squared all over x squared minus 4x plus 3. Okay? That's the other way I could do it. Now it says we want to multiply all that by 3 and then put in 2 for x. So let's put in 2 for x here. So I'm going to have 2 fg of 2. Okay? So we want to put in the 2, so we have 2, and then we have 2 squared. And I'm going to go all over 2 minus 1 is 1, so 2 subtract 1, multiplied by 2 subtract 3. Okay? Now what we end up getting here is, I'm going to get 4, 8 all over, that's 1, and multiplied by negative 1 is going to end up giving me negative 1, which gives me negative 8. Okay? Hopefully you understand that. Okay? I believe. Yep. Yeah. Okay? Now, we want, what was it? 3 f of g of 2. So now I have to multiply that by 3. So it's negative 8 multiplied by 3, which gives me negative 24. Okay? Now, it says, it wants us to evaluate. So there we go with that part there. It's evaluate. So now it says, write the expression in simplest form of an addition. So we want the sum of f of g of x. Okay? So the sum of fg of x. State any restrictions on x. Okay, so now we want f is g of x. So, there we go. 2x all over x minus 1. And we're adding x all over x subtract 3. So these are now rational equations that we're adding. Well, what can x not equal? X cannot equal to 1 or 3, like kind of stated way up above. Alright? Now we also need here common denominators, right? In order to add these, I need a common denominator. So I'm going to end up getting 2x multiplied by x subtract 3, because my lowest common denominator is x minus 1, x subtract 3, all over x minus 1, x subtract 3. And then we have to add, this is all going to be multiplied by x subtract 1, x subtract 1. So we have x multiplied by x subtract 1. This side was all multiplied by x over 3, which will end up giving me, so over 2x squared minus 6x plus x squared minus x, all over x subtract 1, x subtract 3. Simplify this a bit more. I'm going to end up getting, combine these together, I'm going to get 3x squared, and then we're going to have minus 5x. Oh, sweet. 6 minus 7x, minus 7x, sorry, all over x subtract 1 and x subtract 3. And I could even take out here if I want, I could try and factor out, I could take out an x. So what we could be left with is x, and we have 3x subtract 7 all over x minus 1, x subtract 3. Okay? Now this is as simplified as we can get it, and my restrictions, x cannot equal to 1 or 3. And I look at this, nothing can cancel out, so we have to leave it as is. And that's it. Now let's take a look at the next one. It says, write the expression's simplest form as a division in state restrictions. Alright, so we want division. So if we remember, let's write this out, we want f of g of x. So we're dividing rational functions. So if you remember, we have to do leave same, changey, rangey, uppy, downy. But to start off, I'm going to write out each of my equations. So we have 2x all over x subtract 1. And then we have to divide that by x all over x subtract 3. So we're going to leavey samey, changey, rangey, uppy, downy. So we leave the first one the same. We change the sign, changey, rangey, and then uppy goes down. X minus 3 all over x. So from before here, we knew x cannot equal to 1 and 3. Okay? But now we also know x also cannot equal to 0. Alright? We have to add that one more in there. Now we could solve this a lot easier. This is just a simple multiplication. Just set that up. This is centered. So we multiply this together. I'm going to get 2x squared, and we minus 6x all over x squared minus x. And that is this simplified as possible. Or we could factor out and we could leave it like that. But that is that question there, simplified. But one thing could cancel off here. Oops, those x's could cancel off. So I could end up having 2x minus 6 all over x subtract 1. There we go. That is your final answer. X cannot equal to 1, 3, or 0. Alright? Hopefully you understood all that. It was a little bit of review from rational expressions and everything. And if you have any problems, don't be afraid to ask me tomorrow as we work on this together as a class.